Galactic collision reveals cosmic magnetic superhighway. Astronomers have mapped a powerful magnetic structure within the colliding galaxy system ARP 220, located 250 million light-years from Earth. This discovery offers unprecedented insight into the forces driving intense star formation and the ejection of matter at speeds reaching 1.1 million miles per hour. The research, conducted using the Atacama Large Millimeter/Submillimeter Array (ALMA), reveals a magnetic superhighway channeling gas, dust, and energy through the merging galaxies. The collision and its implications ARP 220 is a rare, nearby example of ultraluminous infrared galaxy systems that shine with the combined light of 100 or more Milky Ways. It formed from the merger of two spiral galaxies, and its dense dust clouds hide extreme star-forming activity. Studying ARP 220 is crucial because it mirrors the conditions of galaxies that existed over 10 billion years ago, when the universe was much younger and collisions were more frequent. This research helps scientists reconstruct the early universe's chaotic growth. Magnetic fields as the driving force. The ALMA observations show that magnetic fields aren't just along for the ride. They actively launch and shape the powerful galactic winds escaping ARP 220's cores. These winds, traveling at 1,500 times the speed of sound, carry away gas, dust, metals, and cosmic rays. Previous theories attributed these outflows primarily to star formation and black hole activity, but the new data confirms magnetism as a key player. The researchers mapped the orientation and strength of magnetic fields using polarized light, revealing details within the galaxy's dust-enshrouded cores and molecular outflows. One striking feature is the magnetic superhighway, a nearly vertical channel of magnetized gas streaming outward from one of the galaxy's nuclei. Magnetic order in chaos, the western core of ARP 220 displays a well-ordered magnetic structure aligned with the bipolar outflow, indicating that the field accelerates escaping material. Meanwhile, the eastern core shows a spiral-shaped magnetic pattern within a dense disk, suggesting that large-scale magnetic order can survive even in turbulent mergers. A highly polarized bridge of dust connects the two galactic centers, funneling material and magnetic flux between them. This connection emphasizes magnetism's role in governing matter flow during galactic collisions. The magnetic fields in these outflows are hundreds to thousands of times stronger than those found in the Milky Way, influencing how gas cools and forms new stars. Early universe implications. These findings suggest that strong, organized magnetic fields were common in the early universe, especially in starburst galaxies. By shaping galactic winds, magnetism likely played a major role in determining when galaxies stopped forming stars and how they enriched intergalactic space. As astronomers apply these techniques to more distant systems, they expect to find similar magnetic highways throughout the cosmos. ARP 220 provides a vivid reminder that unseen forces leave an enduring mark on the visible universe. The discovery underscores the fundamental role of magnetism in galactic evolution, offering a new lens through which to understand the universe's past and future.